Hello my dear students, once again welcome back to your online class. So in today's video, we'll be discussing on the chapter vector which comes under the section B of your mathematics syllabus. Now to begin with what is vector, so you must have learned that all the physical quantities, it can be classified into two types. Okay, one having only the magnitude that is known as a scalar and the other having the magnitude and as well as direction which is known as a vector. Okay, so in vector usually we deal with any physical quantities which has a magnitude and as well as a direction. So you have learned quite different types of vector in your junior classes as well. So here we'll also be discussing about the vectors in the three dimension. So what is a three dimension now? So till class 10 we have studied about the geometry in two dimension in which we have only the x-axis and the y-axis. But apart from that there is one more axis which is a z-axis, and in that case we have a three coordinate system, one belonging to x, one belonging to y and another belonging to z. Okay, suppose if I draw a three dimension, three axes x, y and this z. Though Z cannot be drawn on a plane of a board, okay, but here just to represent, I have drawn it inclined at some angle. Actually, this Z axis is perpendicular to both Y and X. Now I take any arbitrary point, okay, arbitrary point A, okay, which is in a space, not in a board, it is somewhere here, okay, and then I join it with the origin. Okay, so your vector A can be represented by R. Okay, and if you drop the projection of the point A on the plane x, z, okay, so I get a certain point here. Okay, projection here means the shadow. Okay, if I draw the shadow of the vector OA in the plane x, z, so what you can do, you can find the corresponding z coordinate, you can also find the corresponding x coordinate, and you can also easily find the corresponding y coordinate from the point A itself. Okay, so now this vector in terms of x, y and z, it can be represented as the vector r will be equals to x I cap plus y j cap plus z k cap. What is I cap, j cap and k cap? They are the unit vector along the x axis, y axis and z axis respectively. So here in this video we will be learning about the multiplication of the two vectors, in which we will be learning about the cross product and the dot product. Like the example of a dot product is like the work done. Okay, so we have studied in class 10 that the work is a scalar quantity, but the work is the product of force and displacement. So in that case, when we multiply two vectors such that the outcoming product is a scalar, it is known as a dot product. Okay, so it is a dot product. So dot product, it gives us scalar quantity, and the cross product is the one in which we multiply the two vectors, and then the vector we obtain as a product is also a vector quantity. So we'll be doing some of the problems related to the vector and help you to understand how to solve the problem based on the vector multiplications and the some other properties of the vector to find the unit vector along the given vector. Okay, so here it is, find the unit vector in the direction A is equals to 3 I cap minus 6 j cap plus 2 k cap. Okay, so to find the unit vector, it is, so the unit vector of a given vector in the direction of a given vector is always equal to the given vector, that is the vector A divided by its magnitude, which we also call the modulus of a given vector. So the modulus of a given vector, how it's calculated? So the modulus of a given vector is simply equals to under root of the x square plus y square plus the z square. So here I have 3 square plus minus 6 square plus 2 square. So which will give me, so 3 square is 9 plus 6 square is 36 plus 2 square is 4. So total I will get this one as 36 plus 9 is, it gives me 45. 45 plus 4, it gives me 49. So which is equals to 7. So now what will I do? So therefore the unit vector will be equals to the given vector, that is 3 I cap minus 6 j cap plus 2 k cap divided by 7, or you can also write this one as 1 by 7 into 3 I cap minus 6 j cap plus 2 k cap. Okay, so this is how we find the unit vector along the direction of a given vector. The next type of question we'll have is find A dot B and A cross B if vector A is this and the vector B is given that much. So remember that the dot product of the two vectors is calculated as vector A dot vector B is simply the modulus of A into the modulus of B into cos of theta, and the vector A cross vector B is equals to modulus of A into the modulus of B into sine of theta. Now let us think about this cos theta and sine theta. So what is the value of cos of 0 degree? So cos of 0 degree is 1 and cos of 90 degree is equals to 0. Similarly, we have sine of 0 degree is equals to 0 and cos of 90, sorry, not cos, it is the sine of 90 degree is equals to 1. So in this case, if we multiply the two vectors, okay, if we find the dot product of the two vectors which are parallel to one another, that means which are in the same direction, it gives me 1. And if I multiply any two vectors which are normal to one another, it will give me 0. But here in case of the cross, it's the reciprocal of the previous. So in this case, so if I multiply I dot I, it will give me 1. Similarly, j cap dot j cap, it gives me 1, and k cap dot k cap will give me 1. And for rest, all it gives me 0. That means if I multiply I into j, sorry, I dot j or j dot k, okay, in or any two vectors, if you find the dot product, it will give me 0. But the case is different in case of a cross product. So in case of a cross product, the I cross I is equals to 0, j cross j is equals to 0, and k cross k will give me 0. Now to find the cross product of any two vectors which are perpendicular to one another, we simply follow this one. So we write I, j and k. Okay, I cap, j cap and k cap. So if you multiply I cross j, it will give me k. If you multiply j cross k, it will give me I. Okay, but if you multiply the same in the anti-clockwise direction, so it will give you the negative one. That means I cross k will give me minus j cross I will give me minus k. Okay, so you need to follow these rules in order to find the dot product and the cross product of the given vectors. So keeping this in mind, we'll try to find the cross product and the dot product of the two vector. So first, let us try to find A dot B. So what you will do, you will simply write A is equals to, so it is I cap plus 2 j cap plus 3 k cap dot, I have, so here I have no I, so that means it is 0 I, so which you no need to mention, so it is minus 2 j cap plus 4 k cap. Okay, so as stated earlier, you no need to multiply I with j, I with k. Simply I will multiply I with I. Here I do not have any I, so it will give me 0 I cap. Plus, now I will multiply j with j. So 2 to the I is 4. So it is minus 4 j dot j, it is 1. Okay. So similarly, I will multiply 3 4 the 12. So it gives me 12, k dot k is 1. So simply this will give me 4 minus 12 is 8. Okay, so A dot B is equals to 8, and 8 is a scalar quantity. So this is what is meant by the dot product. So when we find the dot product of the two vectors, we get a scalar quantity. So similarly, if you try to find A cross B, okay, so what will I do? I'll write the same thing. So it is I cap plus 2 j cap plus 3 k cap. In cross minus 2 j cap plus 4 k cap. So in this case, we have learned that I cross I will be equals to 0. So you do not have to multiply I with I, but I is to be multiplied with j and k. Similarly, j, you don't have to multiply it with j, but you have to multiply it with I and k. Okay, so what will I do? I'll simply follow the only. So this into this and this into this. So it will give me. So I'll write it here I, j, and k. Okay, so I am multiplying I with j. So I dot j, it will give me k. So here it is 1, there it is 2. So it will be minus 2 I into j, it gives me k cap. Okay, similarly I will multiply I with k. So the coefficient of I here is 1. So 1 into 4, it gives me plus 4. Now I into k. I into k, it will give me minus j. Okay, so this symbol therefore it becomes minus j cap. Now I will multiply 2 with this one. Okay, so since you don't have to multiply j and there is no I, so you just have to multiply j with k. So plus into plus it is plus, 2 8s are, 2 4s are is 8. Now here j into k. So j into k it will give me I. Similarly, I will follow for the k also. So now k plus into minus, it gives me minus. 3 into 2 is 6. K into j. Now k into j, it will give me minus I. Okay, so I cap. So minus I, it gives me plus. Now again, k, I don't have to multiply it with k. Okay, so finally, adding the like terms, I'll get. So you'll write I in the beginning. So 8 plus 6, it gives me 8, 9, 10, 11, 12, 13, 14. So it is 14 I cap minus 4 j cap minus 2 k cap. Okay, so therefore, A cross B is equals to this much. Okay, so that is how we find the cross product and the dot product of the two vectors. So having known the concept of the dot product and the cross product, this concept can be utilized to find the condition of perpendicularity and parallelism when the two vectors are given. So just now we learned that if we find the dot product of the two vectors which are mutually perpendicular to one another, it gives me 0. So how will you do? Suppose if you are given two vectors, vector A and vector B. Okay, so in this case, if you find that if I get vector A dot vector B, if it gives me 0, that it means that the two vectors are perpendicular to one another. Okay, so this is the first condition for the perpendicularity. Now the second one is for a parallelism. So just like in case of a cross product, we saw that if I multiply, if I find the cross product of I with I, it gives me 0. So the second one is if the cross product of the two vectors, if vector A cross vector B, if it gives out 0, then it means that the two vectors are parallel to each other. Okay, so using this concept, you may do the questions based on the conditions or where the question asks you to find under what conditions or for what value of x or y the two vectors are parallel or perpendicular. So you will use this concept. If A dot B is equals to 0, the two vectors are perpendicular to one another, and if A cross B is equals to 0, then it means that the two vectors are parallel to one another. Okay, so there are a number of examples given in your book. So please students try to solve it as much as you can. Thank you.